Good morning to another short video on chemistry. In today's topic, we'll be talking about the different types of chemical reactions. So there are two types of chemical reactions, exothermic reactions and endothermic reactions. Now, in endothermic reactions, heat energy is absorbed in from the surroundings, whereas in exothermic reaction, heat energy is released into the surroundings. So the first main concept is enthalpy change. Enthalpy change is denoted by delta H, and it basically is the difference between the total energy absorbed and the total energy which is emitted by a substance. Endothermic reactions are always characterized by a gain in energy, and thus a positive delta H sign, whereas exothermic reactions are always characterized by a negative delta H sign. Now we'll be seeing how the graphs are depicted in the questions. Now they tell you to label the activation energy, which is represented by EA. Activation energy, as we talked before in the chapters, is the minimum amount of energy which is required to start a chemical reaction. So obviously it will always start from the reactants and it will go to the activated state, which is the peak of the graph. If they tell you to label it, it will always be in the forward direction and it will be till the peak of the graph. However, in exothermic reactions, the enthalpy change, if they tell you to draw it, you have to remember that it is always between the reactants and the products. And you can see that as in exothermic reactions, as the reaction progresses, the products have eventually lesser energy than the reactants because the net energy is emitted out. So the delta H sign is negative and it goes downwards. Now, in endothermic reactions, the complete opposite occurs. In the activation energy is from reactants to the activated state, same. However, in this case, the delta H is positive, and thus it will be in the upward direction from reactants to products. Thus, the arrow will be like this. So now I'll tell you that what are some basically examples of exothermic and endothermic reactions. You must always know that endothermic reactions are involved in bond breaking. Since bond breaking requires breaking of bonds, it's always obviously requires energy. Whereas exothermic reactions involve basically cooling of the substance. So, for example, bonds are formed when ice is formed from liquid water at 0 degrees. Now, the typical questions which are basically come in the exam are whether to determine whether the following reaction is exothermic or endothermic after calculating. So, as you can see that after the arrow, these are the reactants and these are the products. So, obviously bond formation has occurred, whereas this is the reactant side. So, we'll calculate the energy which is required to form the bonds and we'll subtract it with the energy which is required to break the bonds. Here we'll be given the specific bond energies. And for example, we've calculated that there are CO2. So basically CO has double bond between carbon and oxygen atoms. And since this one a single CO has 803 and requires 803 kilojoules of energy, so 2 moles of CO2 would require double. We add them up this and similarly we add the reactants. Obviously their bonds need to be broken and thus this is formed. And when we subtract it, the answer comes in negative. Whenever we see the sign negative, it always means that the reaction is proceeding in an exothermic way. Now, some of the examples of exothermic reaction in our daily lives you need to remember, for example, in the combustion of fossil fuels, which are to drive our daily cars, as well as respiration, the process of respiration, which releases energy, and even neutralization of an acid and a base to form salt and water. Uh, All these basically reactions basically release energy and lead to bond formation, whereas on the opposite spectrum, endothermic reaction absorb energy to make. And then the typical examples of endothermic reactions are photosynthesis, the decomposition. Just by the word, we can know that the compound is being broken down by adding heat energy to it. To calcium carbonate, you must also know that calcium carbonate is known as lime, so it is broken down into calcium oxide and CO2. We leave it there and continue in the next part of the chapter in the next videos. I hope you like the video. Thank you.